Hello everyone! With cooperation with the Duke Canine Cognition Center and Duke Engineering, we are proud to bring you today's presentation on our puppy crate redesign. I am Adrian Rocha, and my teammates are Ian Hockenboom, Rita Acharji, and Ava Jarrell. Now, before we begin, I want to pose a question to you. Where do service dogs come from? It actually all begins with dog breeders, which breed their dogs until the age of 2 to 3 months. Afterwards, there are many paths which can be taken, one of which include research institutions, like the Duke Canine Cognition Center. Here, they're given very basic socialization skills and training. Afterwards, they're given formal service dog training, and herein lies the problem, because around 50% of all prospective service dogs fail their final examination. And up to this point, lots of resources have been exhausted on each individual puppy, and at the scale at which the service dog industry is, we are talking millions of dollars lost. Now, what the Duke Canine Cognition Center hopes to identify and anticipate are certain sleep patterns that make a good service dog in order to prevent the waste of resources earlier down the chain rather than later. And to understand why the Duke Canine Cognition Center has a problem, we need to understand how they collect data. There's two main methods of data collection. One, which includes an activity monitor latched on to the puppy's neck. Another is through video recording for visual sleep behavior analysis. On the top of our slideshow, you can see a wire crate. This allows for camera visibility, but not safety, because the wire can catch on to the vital collar that the puppies wear and possibly choke them. The bottom kennel is completely safe for activity monitor usage, but is not camera visible. And so here are the alternating problems between the two different types of cages. So the Duke Canine Cognition Center wants a puppy cage that is both safe and camera visible, as well as adjustable, as seen in our problem statement. And now Ava Jarrell will deal with our initial prototyping.
We did our initial prototyping on a small plastic puppy crate given to us by our client, and then moved to a larger puppy crate, also provided by our client during the second stage of prototyping. We began the first stage of prototyping by cutting the top out of the small plastic crate. We then took measurements of the hole that we made and began making prototype tops with those same measurements. Prototype 1 we hand cut from cardboard. This was merely to assess the correctness of our measurements. We decided that the top cutout needed to be longer and wider, so we added about an inch to the length and to the width and laser cut prototype number 2. This was slightly too long and too wide, so we adjusted the measurements again and laser cut on cardboard prototype number 3, which had the perfect fit for our small plastic crate. As a result, we laser cut prototype number 4 on acrylic with the same measurements as prototype 3. The only difference between the two, besides the material, is that prototype 4 is cut in half due to the 24-inch maximum length for laser cutting acrylic pieces. Here you can see the top view of our crate with the acrylic top screwed in, and to the right of it is the entire view of our small crate prototype. Again, here are two more images of our small prototype crate with the flexible arm camera mount attached to the crate by means of our first camera mount prototype.
The first prototype, the arm was attached to the aluminum brackets using a C-clamp that came with the arm. This setup did a poor job distributing the weight of the arm, and so we moved to a 3D printed base that no longer required the C-clamp. The first model still did not adequately distribute the weight, and so the base was extended further down the side of the crate for the third iteration. This did adequately distribute the weight, and it was our final solution for the camera mount base.
For our final prototype, we went through the same prototyping process as before with the smaller plastic crate, but the features of the design are now scaled up. We also made a couple of additions to the large crate that were not made for the smaller crate. In the second image, you can see our 3D printed camera mount, which holds up the flexible arm. In the third image, you can see the two handles that were installed on either side of the crate by cutting two holes and inserting rubber grommets for improved comfort when carrying. In the first image, you can see our laser-cut acrylic door cover. To achieve this final prototype, there were two cardboard prototypes and one acrylic prototype made for the small puppy crate, and two cardboard prototypes made for the large puppy crate. The tabs at the top and bottom of the door cover are folded over the wire crate door by means of acrylic bending in order to permanently secure the door cover to the door. In the second image, you can see the acrylic top, which is similar to the acrylic top for the small puppy crate, but it is much larger. This top is also cut into two pieces. In the third image, you can see our laser-cut acrylic interior partition. This is a new feature that was never created for our small puppy crate. In order to achieve this final prototype, we cut 6 slits in the bottom half of the crate in order to create 3 levels of adjustability. Then, 3 cardboard partition prototypes were created. One was hand-cut on cardboard, while the other 2 were laser-cut on cardboard.
For our testing plan, the smaller crate was tested for visibility and passed, but we were unable to acquire a camera from the DCCC to complete testing on the larger model. For durability, we assessed the damage after having a larger distressed puppy in the crate for 15 minutes and no damage occurred. It took less than a minute to clean the crate, so it passed cleanability. However, after 30 minutes, the crate had not dried, so it failed breathability. The drying conditions were less than ideal and heavily contributed to the failure of the test. For the future, we recommend towel drying rather than air drying.
As you can see, our team has made many enhancements to this crate, including handles for added mobility, quick release pins to make it easier to disassemble and reassemble, a camera mount as well as an adjustable arm, an interior partition that allows you to adjust the interior size of the crate depending on the dog size, as well as an acrylic door cover to ensure that the puppy's sleep monitor collar does not get caught on the wire of the door. We of course also added a window on top so that the camera could record the puppy while they sleep from the camera mount. Here one of my fellow group members can be seen showing how easy it is to assemble the crate using the quick release pins, as opposed to having to screw in each attachment point on the crate to secure it. To insert or adjust the partition, you simply slide it into any one of the 3 slots available in the crate while the top is removed. When you have the partition on the setting you want it at for the puppy, you simply place the top on and secure the crate together. Once the crate is secured together, the partition is in place and the size is set. The puppy's activity monitors that they wear inside the crate are liable to be caught on the wire door, so we permanently installed an acrylic cover to the inside of the door. As you can see, it does not at all hinder the function of the crate's door. The orange 3D printed camera mount base seen here is fastened to the crate with 5 quick release pins. The adjustable arm then fits into this mount with a single peg. As you can see, it can raise the camera well above the window and give it a good viewing area so that it can see the entire inside of the crate. This concludes our demonstration.
So the next steps are that the DCCC wants a crate for each of the puppies they have, which usually ranges from 5 to 7 each semester, so there are more crates that are needed. The crate still lacks good floor contrast for filming dark-colored puppies, so an option for a light-colored floor is needed. And lastly, while the partition passed durability tests, we would still like to add stabilizers to the top so it is secured at the top and bottom. In summary, we achieved our final goal of creating a safe puppy crate with camera visibility, and the DCCC will be using the crate for future research.